Thank you for the opportunity to present my work here. I think this virtual meetings is really something exceptional, and we couldn't imagine that before the COVID. So my talk is Naturalistic Paradigm with fNIRS Imaging, a potential approach for basic research and diagnosing disorder of consciousness. And I'm Vadim Axelrod. I'm head of the lab at the Gonda Multidisciplinary Brain Center at Bar-Ilan University in Israel. And the main contributors of this work are Tamar Mizrahi. She is a MD, physician and PhD student in my lab, and Noam Sommer, who is a master student. So the naturalistic approach, most of us know that it started with the work of Uri Hasson, Rafi Malach, and colleagues who showed movies in the fMRI scanner. A few people know that actually there was a work already several weeks, which was published several weeks before this famous work in Science and Human Brain Mapping of Andreas Bartel and Semir Zeki. They also used movies and showing the scanner. So why we would like to use naturalistic approach, why it's interesting is because this is a way to create more naturalistic, more, in other words, more ecological stimulation in the laboratory settings. And the main premise of this approach is that when two people are watching the same movie, the brain activity in the corresponding regions of these people, when they're exposed to the same naturalistic stimulus, might be similar. So the regions are driven with similar activity. Not all the region, obviously. And in the approach for analyzing this, which is called intersubject correlation approach, there are many developments in the recent years. I'm here talking about most basic analysis, and this is one which I used in this project. Is that suppose we take seed regions in each of the brain, corresponding regions, we extract a time course, and then we correlate between them. So this procedure is repeated for different regions of interest, and the idea is that if the region, if there is a correlation in specific region, we conclude that this region, to some extent, this activity was related to the movie. It was processing the movie, because otherwise, for example, in resting state, if we just use the resting state, we are not expecting for the subject to have this correlation in any of the regions. And most of the research with naturalistic stimuli were conducted using fMRI. And the question is functional near-infrared spectroscopy fNIRS sensitive enough for use with naturalistic paradigms? Note that both fMRI and fNIRS signal are hemodynamic, so fNIRS might indeed be sensitive as fMRI, similar to fMRI, because most of the studies used fMRI and it was successful. We can expect that probably with fNIRS we can also be successful. And the approach of using naturalistic stimuli fNIRS might be particularly suitable for testing disorder of consciousness patients, and we'll talk about it later. So a few words about fNIRS. Here is a diagram of the fNIRS. fNIRS is obviously non-invasive method, and here in green we have the emitter, and in blue there are two detectors. Obviously, it's just a schematic view. There might be much more than two. And what we actually get is that we measure the absorption of the near infrared light in the cortex. And we get two types of signals. One is oxyhemoglobin and another one deoxyhemoglobin. So in contrast to fMRI, which we just have a bolt, here we have two types of signals. And here is the outline of my talk. In study 1, we used a short comedy movie to test the reliability of fNIRS signal and its correlation with the behavioral scores. And this work has been already published in the Frontiers in Neuroscience journal just recently. And in study 2, we use auditory storing classical music as well as their scrambled counterparts as a design which can be used, which we plan to use with a dog patient. Not exactly this design, but we will see that that music doesn't work as good as auditory story, but this is the idea. And here's a montage used in both studies. we use prefrontal recording. So we use the Octamon fNIRS device, Artinus, and there were 4 emitters and 1 receiver per hemisphere. So in total, we have 4 for HBO, oxyhemoglobin, and 4 deoxyhemoglobin channel per hemisphere. And here's the design of study 1. In fNIRS experiment, we have 53 participants. It was healthy participants, and subject watched 3-minute fragment of comedy silent movie of Charlie Chaplin. It was a circus movie, and the fragment was probably the most famous of this movie and one of the most famous of Charlie Chaplin when the Chaplin is in the cage with the lion. And in addition, we have the behavioral experiment of 20 subjects, which watch the same 3-minute fragment, this time only once. But after that, the participants continuously rated how funny each point was. It was static frames for each 200 milliseconds. And the idea was to check how the humorousness of the movie during the whole period of the movie. Of this period, no segment of the movie. So the study 1, fNIRS data analysis, we use the standard pre-processing steps that include temporal smoothing, detrending, bandpass filtering, artifact exclusion. We also time courses within hemisphere were average because of the proximity of the channels. The activity is quite strongly correlated. So we present the data for left hemisphere and for right hemisphere. We usually leave one subject out, inter-subject correlation analysis, because this analysis mimics what we later will use with analysis of the patient data. Here, how works the leave one subject out analysis, and here's a toy example. What you see here is in the color for traces individual data. Suppose we have n subjects. So here we show n-1 subject, and the bold black line is the average time course of n-1 subjects. And here is the subject number n. And now we correlate between the average of n-1 and the subject n. And this procedure is repeated n times for each subject. So for each subject at the end, we get the correlation with n-1 remaining subjects. So here are the results. I show you the results for left hemisphere. For the right hemisphere, the results were similar. On y-axis, you see the intersubject correlation. We have HBO and HBR signals. And first I show the repetition 1. Remember, there was 2 repetitions of the movie. And you can see that there was beyond 0 in both cases, and then HBO, the activity was higher than HBR. And here's the repetition 2. In repetition 2, again, it was beyond 0, but the effects were much weaker. So what we conclude, the strong beyond 0 intersubject correlation, particularly in repetition 1. I probably need to explain that beyond 0 correlation, it means that there is indication of processing of the movie. This is important to understand. And the HBR there was a beyond 0 intersubject correlation, but it was weaker than HBO, but it was still beyond 0. Actually, there are many reasons why the correlation in the second repetition will be lower. For example, subject could be less attentive. They can it could be a bit more boring because it's the same movie, etc. So it's an inherent part of the design. And next, we asked about, we wanted to test directly the reproducibility of signal across repetitions. So here we just averaged the activity of 53 participants. And the red trace is the first movie repetition, the blue trace is the second movie repetition. And what you can see here is that there is a correlation between 2 movie repetition. This means that some level of replicability of the signal. You can also see the shades are the standard deviation. There is a large standard deviation, and actually it was larger in the second repetition, the blue one, which fits nicely with what we get that in the intersubject correlation was low in the second repetition. And here's the results in HBR. Also, again, we get the correlation between 2 repetitions, but it was lower. Okay, so far what I showed you that the fNIRS signal reflected some level of movie processing, and the question is there more direct evidence that fNIRS signal reflects that we can find that fNIRS signal reflects the cognitive processing, not just the correlation between two parts or following the movie, because it could be also as soon as we follow the movie, it could be more global modulation and so on. So we seek for some more direct cognitive processing, indication of direct cognitive processing. And just to remind you that we had an independent group of participants that continuously rated how funny each point was. And here are the results. What I show you here, the blue and red traces are the fNIRS traces that I just show you, this time without standard deviation. But here I also added the green trace, which is a humorousness score, the rating of how funny was movie in each fragment, because we standardize the ratings. We can show it's in the same plot. And what you can see here is a clear anti-correlation between two. It was for the first repetition, it was -0.5, for the second -0.26. And it was for HBO channel. For deoxy, we didn't get a correlation. So in this specific case, HBO was more sensitive. If you wonder about interpretation of this result, one possible interpretation is that in non-humorous situation, the prefrontal cortex activity inhibits humor-related behavior. And during humorous situation, no inhibition is needed. Actually, there are some single case examples of not single case of patient who, after lesions of the prefrontal cortex, became less depressed, more funny, etc. So this can be the explanation. But in any case, what is important is that we do show the correlation between the neural activity and the behavioral score, which is important for understanding how reliable the activity and that it actually reflects the cognitive processing. So the conclusion of study 1, fNIRS might be a sensitive tool to use with naturalistic stimuli, and we also, with the approach, can be potentially maybe used for clinical diagnostics. And here, let's talk a bit about dog patient and their evaluation. Actually, I have too limited time to go deep into this. So the main idea, I believe most of you know, that neuroimaging is valuable in the evaluation of dog patient who might not respond to behavioral commands, which is the term cognitive motor dissociation. There are many neuroimaging approaches that have been used for the last 25 years. And one of the most recent and interesting is the approach which was pioneered by Owen, Natch, and colleagues who use the naturalistic stimuli in neuroimaging. In their case, they used fMRI. So what is the motivation? The motivation is very simple. If we can find evidence that a patient can follow the stimulus, then her cognitive level is probably relatively high, because we cannot expect the patient which is completely unconscious to follow the movie or auditory story. So here are several additional considerations for what we did with regard to fNIRS and naturalistic stimuli for dog diagnostics. So what is the benefits of such approach? First of all, fNIRS can be used at the bedside. You know, fMRI is an excellent tool, but to bringing dog patients to the fMRI is not very easy, and not all hospitals also have fMRI. So fNIRS can be very, very useful to this extent. fNIRS is safe. Not that fMRI is not safe, but you know, if you want to test someone repeatedly, you probably would like to use device like fNIRS, like EEG. So, for example, you can use fNIRS every day and test patient's state. And additional benefits, fNIRS is relatively tolerant to motion artifacts. At least it is believed to be more tolerant than EEG. It's not that it's completely tolerant, but still it is tolerant. And several additional considerations, which also drove our design here. It is better to use auditory stimuli and not video with patients because the ocular system and vision can be impaired in this patient. So it's better to use auditory stimuli. And it is important to make imaging of the high level regions like frontal lobe, so we can test high level cognitive processing. Because otherwise, think about it, if we make imaging of auditory cortex, we can get an indication that the patient is processing movie auditory story, but it will be just auditory sound. So we would like indication of high level cognitive processing. And this is, as I showed you before, this is a montage we used of the frontal lobes. And here's the design of our study. We used 24 healthy participants, all not healthy, we didn't run yet the patients. And we use auditory stimuli, 9 minutes each. It was a passive listening to mimic the design with patients. So the story was, which is the slow story of a novelist, American novelist O. Henry. And the scrambled story was another story of Henry. We couldn't use the same story because it was the within subject design. Note that it is not that suspenseful story like which was used by Owen, and as we will see, it works quite well. And in addition, we use 2 musical stimuli. It was classical music, Tchaikovsky and Rachmaninoff. At least in my view, it was very, very, very emotional. And it was also face scrambled classical music. This time we could use the same stimuli to scramble it. And the stimuli order was counterbalanced across participants. And here are the results. First, I show you the comparison between story and scrambled story. What you see here, it's 2 conditions. Small dot is individual subject. Y-axis is a live-one-out intersubject correlation, and large blue dot is the average. And you can see that the correlation for story was much higher than for scrambled story. It was both of them was beyond 0, but in story it was much beyond 0. For the oxy, it was oxy. For the oxy, the picture was very similar. What is important is the story was much higher than the scrambled story. This was an average, much higher. What is also important, we tested at individual level. So we found that in 75% of the subject, the story was higher than the scrambled story. We used bootstrap correlation comparison to statistically evaluate the result. So this is the sensitivity of our approach, and I think it's relatively high. And next, we compare the music versus scrambled music, and you can see there was no major difference, almost no difference at all between music and scrambled music. The same was oxy and deoxy. So the group level, no major difference between 2 conditions, which make us conclude that music is not effective, not efficient stimulus to use for dog patient diagnostics. Finally, not for clinical purpose, just for understanding, we compare directly also the story versus music, and you can see that there is a major difference between story and music, which confirms the idea that the story derives the frontal lobes much better than the music, even given that the music was very emotional. Obviously, it can be said that we don't know, maybe if we have to use another type of music, it would be different. I can't know, but at least in my opinion, the first concerto of Tchaikovsky is so emotional that it's difficult to find something else. But different people, might behave differently. So the conclusion that we reach, that comparison between story and scrambled story might be used to prove cognitive level of dog patients, and how the patient data will be analyzed. So here it was leave one subject out. In this case, we don't need to leave one subject out. So for a group of healthy participants, for each condition, we will calculate the average time course. And the patient's time course will be correlated with the healthy group time course for each of the conditions. And finally, I would like to make a note about fNIRS global signal effects, because it's a very important point when you do fNIRS experiments. We recorded only in the frontal lobe, so the global signal could not be discarded. So some of our effects might potentially be explained by global effects, like a global modulation. We can't know that. In the future, it will be preferable to add short separated channels, which can record the global signal, which can be later discarded. But critically, the most critical point is that for the clinical diagnostics, global signal doesn't confound the interpretation. Why? Because we record the activity in the frontal lobes. So if we get the correlation between subjects, this means that whether it's modulated, for example, if we take a patient, if we get that the signal in patient is similar to healthy participant, regardless of whether it's global modulation or it's specific processing of the frontal lobes, it still means that the patient processed the content, the flow, the plot of the story. So this will serve an indication that that the patient was able is capable for some high-level cognitive processing. And thank you for your attention.